All right. These powers, what you're going to have to do here is make educated guesses, and I do this so that you actually have to think. The calculator does these very easily. But the problem is, again, people start typing things into calculators and they don't really know if that's the correct answer or not. You know, if the answer is supposed to be 2 and you tell me the answer is 7, if we're talking about powers, that's a big difference. Think if the base was 3. 3 to the second versus 3 to the seventh. You're a little off. All right, so probably the easiest one to start with is 10 to the 0, which is, of course, 1. And then 10 to the first is obviously 10. And the beautiful thing about 10, that's what makes metric so easy, is that when you start having powers, it's 10 to the second power. You can look at it when it's this way. That's almost telling you how many zeros there should be. 100, 1,000, 1, 2, 3, 4, right? 1, 2, 3, 4, 5. Right? So if I were to ask you what is, say, 10 to the 2.5 power, you should know that 10 to the 2.5 kind of fits in here, right? If I had to put it in here, so it better be between those two numbers. Is it exactly in the middle, though? That's the question. And unfortunately, it's not. Because exponentials, when they get going, they kind of start like this, and then they just take off. Okay? So, and it takes off kind of more towards the end. So it wouldn't actually be, say, 400 or 500 or something like that. It would be somewhere out there a little different. But how about these negatives? What's the deal there? Well, this is 10 to the negative 1, meaning 1 over 10, which is 0.1. That's the hard part. When they go into the negatives, it doesn't quite give you as good of an answer as it did previously, because it doesn't just tell you how many zeros there should be. It kind of tells you how many zeros should be on the bottom, but then you need to be able to translate that. So that's 100th. And for those of you that it's been a while since you had to read a decimal, that would be 100th if you had to read that. And so again, this is 1 over really 1,000. 1 over 10,000. Because that's tens, hundreds, thousands, 1,000. This is 1/10,000. And this is 100,000. And once again, if I were to ask you, well, what if I gave you 10 to the negative 2.5, let's stick with the 2.5, you should be able to tell me kind of about where that fits in. So right about here is where that would fit in, right? Negative 2.5 is in there somewhere. And so the number would have to be in between those numbers somewhere, which is on that prerequisite worksheet why I gave you a couple numbers and said, give me a decimal in between there. Okay, to make sure that you could do that. Okay? And I would look at this as being 0.001 and 0.010. Right? You look at it that way. 0.00. So you had to give me 0.00 something between 1 and 10. Okay, yeah, 6. Good enough. That would have been your educated guess. Okay. So any questions on that? And if you're not given a little table like that, you should be able to recreate that on your own with very little time, very little effort. Okay. So let's try this. Well, when you're given a log, what seems to be missing on all of these logs? It's as if I forgot to write it. Yes, the base. So if I ever give you one and it's not written, you don't make an assumption, oh, it's a 3. Well, no, if it's not written, it is understood to be a 10. Because what these are called common logarithms. Okay? So it's just understood, if nothing's written, to be 10. So you don't have to write them in if you don't want to, but you can if you feel more comfortable. Okay? That's what that means. And again, it's important to be able to kind of interpret what that means. And really look at it this way. Well, maybe I think I have it over here somewhere. Maybe not. No, apparently not. So log base 10 of 55. Well, or log base, yeah, 10 of 55. So it's log base 10 of 55. All right. Would equal something, right? That's the problem we're getting. What it's really saying, if you translate it, is 10 to some power has to give me 55. That power is out there somewhere. Do we know what it is right now? No, but should we be able to get close? Yeah. Right now, for example, if you told me 7, that would be a bad answer, right? Because it's nowhere near 7. So you have to kind of find out where does it fit in. Well, if we look at these are all decimals over here, right? So it's obviously 55 is way bigger than that. So you got to find out, well, where exactly does 55 kind of fit in? And because it's the answer part, right? So if I'd say 55 fits in right there. And so 10 to what power do you think? You better tell me that it's between 1 and 2 somewhere. Everybody see the 1 and the 2? So over here, you know it has to be between 1 and 2. You can just kind of write it that way if you want. And right now, I would like you all to just make some educated guess, and it truly is guess. Obviously, don't tell me 2.3. Okay, don't tell me a half. Okay? Find about where you think it is based on how far it is between those two. 55 is more than halfway. Okay? And remember, it starts off slow and really takes off. Okay? I hope everybody has an educated guess at this time. And the exact, for those of you that want to see if you are close, so probably a little higher than you thought, okay? Because again, it does kind of take off. And realize 55 is a little bit more than halfway. So now this one, again, translate the question. It's really saying if this were to equal something, that's what I'm trying to find, it would be 10 to some power has to give me 356 now. All right, well, let's go back here and find out where does that fit in. Now, you don't actually have to write it, but just find out where it fits in. And it was, what again, 356? Is that what it was? Yep, 356. So we got to find out, well, where does that fit in? Well, here's 100. Well, 356 is kind of in here somewhere, right? I would say 356 is probably a little closer. So 10 to the x equals that. So x has to be between 2 and 3. Okay. So between 2 and 3 somewhere. And so make your educated guess, please. And looks like it's a little closer to 100, right? And so you might guess on the lower half of the 2's. I think this one will help you understand how quickly this goes up. Starts off slow and really takes off. $2.55. Okay. Now, this is normally the hardest one for people. Now we're saying, again, it's 10 to some power has to give me 0.005. Okay, so 0.005. So 10 to some power has to give me 0.005. So finding out where that fits in is sometimes the difficulty. Let's see, it's 0.005. Here's how I normally do it. I find something I know is less than, when I go to the negatives, I find something I know is less than that. And is 0.01 less than 0.005? Because that's 5 out of 1,000. This is 1 out of 100, right? So it's bigger than that. Or it's smaller than, but you get the idea. It's smaller than that. So is this smaller than the number I have? It's 0.001. That is smaller than 0.005, right? So 0.005 fits in here. So it has to be between -2 and -3. And I'll do an arrow this time because otherwise it might just look like it's a little weird. So between -2 and -3. The negatives kind of work a little differently, but just give me a decent guess. Because 0.005 is about in the middle. Yeah, the negatives work a little bit different. What I would like you to do is try D through H right now on your own. Get the between by yourself, make your guess, and then we'll come back and I'll tell you the answers. All right, let's see how you did on your between and your guessing here. So how about log base 10 of 0.02 between what and what? -1 and -2? That is correct. And hopefully you got some guess in there. The exact is, well, semi-exact, right? The next one has to be between 3 and 4. And this is the one because this is saying 10 to what power gives you 1? And it's 0, right? It's not between this and that, it's just 0. And so your guess better have been 0 because the exact is 0. Well, that's a good one. All right, the next one. Between what and what? 3 and 4. Now what we can do is kind of compare these two, right? This one was very close to 1,000 and it was 3.03. This one it's between the 1,000 and 10,000, about, it's not really halfway, but it is past halfway. And -3 and -4 for this one. -3.1. Okay. Are there any questions on that one? Any questions? Okay. All right. And what do we have here? A blank page. Awesome. Antilogs. Once again, you notice there's no what? No base. If you see that, understand that it is 10. Now it's anti. So let's think about what we were doing before. Before, when it said log, it was basically solving for the exponent. So if this is anti, meaning the opposite, I'm not solving for the exponent, I'm being given the exponent. You see how that's the opposite? So in logs, you're solving for it. Here it's saying, here's the answer, here's the exponent. And so basically, this problem is saying 10 to the 3.2 equals what? So you see how that's different. It's not asking for the exponent this time. It's actually asking for, kind of where does that fit in? And obviously, it fits in between 10 to the third and 10 to the fourth, right? And 10 to the third is 1,000. 10 to the fourth is 10,000, right? And so if we're talking 3.2, 3.2 is a little closer to 3 than 4, right? And they do kind of start off a little bit slow. So we know between 3 and 4. So why don't you make your guess quick and think about where do you think that is? Well, not between 3 and 4. What am I talking about? What's it supposed to be between? Yeah, 1,000 and 10,000. I don't know what I was doing there. So what do you think? It's closer to 1,000, but by how much? Do you think it gets to, say, 4,000? This one. You think it gets to 2,000? Remember, they start off slow. That's the tricky part. No. The actual answer, or the relatively close to the right answer.
Dude, I have the exact same.
Okay. And so it starts off, it doesn't go very fast, and then it takes off towards the end. Now, it's anti-log. So is it giving me the exponent, or is it asking for it? It's giving. Okay? Because remember, regular logarithms solve for exponents. And so that's what you're trying to find. So if this is the opposite of that, I'm being given the exponent. So between, 10 and 100, very good, if you look back to your table on the other side of the page. And once again, it's kind of closer to the 10 part, right? And so a strange coincidence between A and B. Okay. Now, how about this one? This is saying 10 to some very small power, correct? So that kind of means probably some type of radical involved, perhaps, right? And so if you look on there, it has to be between what and what. This is kind of the harder one. Okay, so it has to be between 10 to the 0 is 1. 10 to the, maybe I'm going the wrong way for you. 10 to the first is 10. Remember, what you're trying to do is find out 0.002. Do you agree it's in between those two numbers? Do you see that? Okay, that's the hard part. Sometimes when you get those decimals, you want to look at the right side, right? But this is the exponent, so 0.002 is between 0 and 1, and so my answer better be between 1 and 10. And it's going to be way closer to which of those two numbers? Way closer to 1. And this one's way out there. Okay. Now, do you see how that works, though, for that one? Does that make sense, how that fit where it did? Okay. Let's do a negative, and then I'll set you loose here. So it's 10 to the negative 2.4 is what it's saying. So maybe just look, where does this number fit in? You know what I mean? Find, where does that fit in? And it fits in between 10 to the negative 2 and 10 to the negative 3, right? 10 to the negative 2 is 1 over 100, which is 0.01. And this is 1 over 1,000, which is 0.001. And so your answer, and it's kind of in the middle, right? And so, again, here's how I look at it. This is kind of 0.001. This is 0.010, right? So I have to find something in the middle. So it's 0.00 something, right? Yeah, not 12, right? That would not be good. But 0.0, something between 1 and 10. Okay, is really what it has to be. And this has to be between, I'm sorry, I should have put 0.01 and 0.001. I don't really care what order you put those in. But it has to be between those two. And you could flip-flop that order, I don't care. And the actual answer is... Okay, so try E through H right now. Take your time. Okay, try and find out where does it fit in. This is the exponent. Okay. All right, let's take a look. So, anti-log. So it's 10 to that power. So again, find out where does that fit. Fits between 10 to the negative 1 and, or not, yes, 10 to the negative 1 and 10 to the negative 2, right? And this is just 1/10, so 0.01, right? And this is 1 over 100, so, wait, that's one, whoops. This, go away. This is 0.01, and this is 0.1. Now remember, is it okay if you flip-flop these? Yeah, that doesn't really bother me. As long as you give me something that's right. So you have to give me basically 0.0 something, right? And just don't give me 0.010 or something like that, right? But 0.0, and let me see what it is. Point 0.02. Yeah, what is that? That's weird. So this one is between, this is big, right? So this is between 10,000 and 100,000. Please realize the acceptable range here is relatively large, so try and narrow it down. It's got to be closer to which one, the 10,000 or the 100,000? 10,000, and by quite a bit. Okay. Anything in the 13,000, 12,000, or 13,000 or 12,000 range, very good. This one is between. This is the one I'm worried about. Very good. 1 and 10. It's very easy to do that one wrong. But really, just find out where does that fit in as an exponent. Which exponents is it between? It's basically between 0 and 1, which turns into 1 and 10. Having anything in the ones is very good. Okay. Even 2 or 3 is very good. This one here, between 0.1 and 1. And so, point something, in other words. Does everybody sure know why that's 0.1 and 1? Okay. Because it is a negative there that's I snuck in there. And so it is basically between 10 to the 0 and 10 to the negative 1. Right? Because negative 0.25 would kind of sneak in here, right? Yeah, and that's why I put these two at the end, because these are the two tricky ones. All right? And so this one here turns into, whoops, the 1, and there's your 1/10, right? And so you make a guess, and it is 0.56. Now, some of you are kind of saying, oh, I did terrible with my guess, blah, blah, blah. But you know what? You gave it at least in an acceptable range. right? Remember those people that maybe the correct answer is 3 and they said 7, and if you're talking about exponents, that's a huge difference. That would be the equivalent as on that other page, on the front page, you know, it was 1.74 and you told me 5. Right? A big difference, and you have to be very much. Anti-logs give you a wide range normally, but logarithms not so big. If you haven't written this down yet, I don't know why. You wouldn't have. But logarithms ask for the exponent, anti-logarithms give you the exponent. And that's that biggest difference. Okay? That should have been written down in your notes a long time ago. Okay? After the first time I said it, you should have written it down. Okay? Do you have any other questions?